All right. Hi. Let's talk file I/O. Previously, we've talked about file I/O, but I don't want to talk just about the syntax that is necessary to work with file I/O. I want to talk a little bit and dive into how file I/O works and how it's not this scary separate thing from C++. It's actually a child of a smaller, bigger class of the I/O stream in C++. So I'm talking about streams. What are streams? So when we're working in computers, data is read from start to finish. So if we were accessing a file, we would be reading the file from the beginning to the end. You can think about it as like data coming in through a stream. Bytes are coming in. I've shown, so more formally, a stream is an object which represents the flow of data. With every stream, there's three components that are associated with it. So number one is the buffer in the memory. You can think of the buffer in the memory being a small capture of the slice of data. So let's say if we were reading through some text, right, that would be the character that we're reading or assessing in the code, the runtime of the code. We also keep track of the position we are in, so the cursor. The stream has a cursor, so if we were accessing through a file, we would be keeping track of the position that we're in the file, as well as flags, which determine if our read in the stream was successful or not. So something more conceptual to understand is like being at the end of the file. That's a flag that we can check with, I think, a .eof at the end of our stream, but a sketch here of what a stream would look like. So you can think about it as a stream being the tap of the pipe, the hole of the pipe, and there's data coming through. And as data's coming through, the cursor is keeping track of where we are at, and we are keeping a slice of that data in our buffer memory, right? And with that data that we're at, we're checking the flags if this was a successful read, if we're at the end of the file, things of that nature. I want to go a little bit deeper into why we use these comparison operators in C++. In streams, data comes out sequentially, right? So if we were reading through a sentence, right, the data is coming in sequentially. For C++, insertion and extraction operators are a way to describe the way we push and pull data in the code. So, for example, here I have some code written out where the data, so you have first name and last name, is coming out sequentially, right? The code should show that sequential order alongside the insertion of characters like a space or a new line break. It doesn't matter what kind of data we're working with. We could also be working with files, and we're still using insertion operators here to show how the order should go out in output on the console, or for example, writing out to a file. So let's talk about the syntax necessary to work with files in C++, file I/O. We need to, in the header of our file, include this fstream library that's necessary to declare within our main function to declare a stream. So here I declared an OF stream, which is the output file stream, but there's also the IF stream, which works with taking input in a file stream, and then we just have the general F stream, which both reads and writes into files. After we declare any file stream, we need to open, so .open, then that connects to a file of our choice. So you would include as a string the title of the file that you want to work with, and then optionally you can pass in a parameter here. These are called modes. One of the modes that you can choose is ios.app, and that allows you to append to a file. We will circle back to this later on, but after we are working with our file, at the end, it's good practice to do a .close, so to close the stream once you're done working with it. Enough of me talking. Let's show this kind of work in action with some actual code. So let's say we wanted to read through this CSV file and work with it, right? Here's some code I wrote. that does that. So here we first include the fstream library, and then we declare our file stream. So we have an in data file stream, we have an output file stream, and then we open our respective files. Notice in this file directory we do not have an output file called formatted.txt. After we call this function, if there is no pre-existing file with this name, it will create it for us. Afterwards, it's good practice after you declare and you try to attempt to open any of the files that you're working with to check. There is a member function for these objects, which is called fail, that determines if the output, if the stream was unable to open the file for whatever reason. Here I return a -1 in the main function to quit the program early if the stream doesn't work. And then I use some vectors here. No need to worry about that because that's not related to the file I/O. But here's something to take note of. When we are reading through a file, here's one way we can read through it while avoiding not touching the end of the file. Trying not to read past the file. We could start a while loop that not only tests a condition to see if there's a successful read in the file, therefore not being at the pass of the file, we are in a legitimate range, while also passing through the input stream or our line here, capturing a line. We can do that with this while loop. So it reads through the file and we capture a line, then we work with it, right? And after that, that's done. Once I'm done working with these file streams, I close them. And however, we can, in the same program, not only close once, we can reopen streams. So let's say that after the data's been reformatted, we wanted a summary at the end of reformatting our file. So in the same formatted data file, we include a summary at the end. We do that by reopening the file, but then we add that mode, that iOS append. And so then we work with it. We create an average age of each person by doing first a sum, and then we divide that sum by the total population. We do a static cast of double to make sure that we're doing a floating division. Anyways, and then at the end we close the file. So enough of me rambling. Let's see how this operates. Alright, so let's see if there's a file here. Alright, there is a file called formatted.txt that went through each, there's 30 people here, and then it shows the name, the age, and the favorite animal here. And we go down, there's a summary. We have 30 people, and the average age was 33 years. Alright, so that's how you can work with file I/O in C++, and hopefully you have a little bit of a conceptual understanding as to how it works. We actually, in this code, we also use another kind of stream called a string stream. So it generalizes a string as a stream, and it has a buffer, and we can work with it the same way we would work with a file. So file I/O is not so different from C in and C out and strings. It's not scary at all. I hope you understood something from this video. Thank you. Goodbye.